Hello everybody, welcome to the moon where we're going to be doing a solar panels tutorial in Stationeers. Okay, we're going to look at a few different setups and how you can set them up to where it's easy or just convenient. First we have a setup here that is pretty much what you would see or what you would try to do early on. You really don't have access to a lot of alloy, so you can't do some IC chips, or you're just not good with MIPS. So you use logic chips. Reader, a math, a memory, a writer, and this right here is your horizontal. Reader, two math, two memory, and another writer, and this is your vertical. Everything in green is strictly data. There is no power on any green wire. Red is strictly power. There is no data on any of these red wires. It is strictly power. Here in your basic logic circuit setup, you have your daylight sensor, which puts out a vertical and a horizontal reading of the sun, which is currently down. If you look at our nice little planet Earth, you'll see that it's at about the 7 o'clock position, going backwards. Okay? So this is the first logic reader. It will take the horizontal reading from the daylight sensor. Then it will put it into a number for the math unit to use. The memory holds a number that the math unit will use. So depending on the orientation of your solar panels and the daylight sensor, you will have to put a value in here so then your solar panel points in the right direction, at least along the horizon. Then that spits out a number that is sent to the batch writer, and your batch writer is set to write to every single solar panel simultaneously, not just an individual one, but all. Then for the vertical, of course, same daylight sensor. Since it puts out both batches of information, you just got to have something that reads the vertical. Again, into the math. Here, this memory unit is going to be set to 75 and is going to be set to add, provided that your daylight sensor is facing up, like this one is. And that's going to take whatever the vertical reading is, plus 75, and it's just going to shoot it out to this one, which will take that number and divide it by this memory unit, which is set to 1.5. So vertical plus 75 divided by 1.5 gives you a vertical percentage of 100 that the batch writer will then put the solar panels to, because when it goes to the horizontal, it is in degrees. When it comes to the vertical, it is in percent. I did not design it that way. That's just how it is. When you get to more advanced levels or more alloys, that sort of thing, or you want to try pips, then programming, which, as you can see, cleans it up a lot. This transformer is just to stop these wires from blowing up. Okay, think of this transformer as like where your load would be coming off the wires. So everything else here is what's required for it to work. And as you can see, the sun went past midnight. So now the solar panels are readjusting themselves to be ready for sunrise towards the east. And on the moon, of course, Earth is north, which is really weird. But, it's a game. The programming on the chip is actually not too difficult. I learned it, so just about anybody can learn it. You can turn off. Okay. Go to Edit. And here we have the programming all fluffed up. So it has names to make it easier to read. Device 0, that's pin, that's pin 0. Registry 0, registry 1, names for it, and definitions. And then we have the start of the actual code. This section here marked by this is just horizontal. It just ignores this and just it loads sensor setting horizontal into registry azimuth. Then it adds azimuth to horizontal offset and puts it back into azimuth. Then it takes that as the horizontal setting and it puts it into everything that has this prefab hash. So this is the prefab hash for the dual solar panels and set batch. That's what this SB is. And of course in vertical, basically everything in those logic chips that you saw in the previous set, that's all right here. Yield just makes it stop for a tick, and then it just jumps right back to here and goes over it again. So now it's in a continuous loop and your solar panel works correctly. Okay. Now if you've just edited it, then you would hit export, pull the chip, put it in, turn it on, and hope you don't get a orange flash. Green light means you're good. And as you can see here, sensor, daylight sensor, and there's no device on anything else. It actually just straight up writes straight to the solar panels through that SB command. So on this setup, everything is simplified even more. Again, the transformer is to keep those wires from blowing up, and it can also represent, where your load is, where it's coming off. The yellow wires is what's different about this set compared to the other two. Okay, because in these yellow wires you have both data and power running across them. All these other solar panels are the dual ones, so they have separate power and data. On these solar panels, your power and data is through the same port. So, yellow cable, data and power. And as you can see, just data is coming through here, just power through here, and just power through there. Super simple. And with this one, for demonstration reasons, I went through and I basically defluffed the code. This is the code stripped down to where there is nothing in here that doesn't have to be in here. No extra spaces, no extra words, no little anything. This is straight up the code. Okay? And as you can see, it works just like the others. Doesn't have to be more complicated than this. Here, this is a little demonstration that I set up to show you how orientation of the solar panel and how orientation of the daylight sensor affects how this system all works. Every single one of these solar panels is pointed, has their data and power pointed to the center of this block. And every single one of these daylight sensors have their data ports pointed to the center of this block. Right now, the dial is set to 0, and 0 is the north sensor. So the sensor is pointing north, the data port is pointing south. And as you can see, the solar panel that is actually properly aligned to the sun is this first one right here. If we adjust this to 1, that changes it to where this daylight sensor is the one being read by the system. And now, as you can see, they're all readjusting. This one is now pointed correctly at the sun. With your single solar panels, when your data and power port is pointed towards the west, then the data port on your daylight sensor needs to be pointed towards the south, and then you don't have to worry about a horizontal offset. So with the data port from your solar panel to your sensor being offset by -90 degrees, that makes it to where you don't have to compensate or offset the horizontal. If you're curious on how I got this code to work, to where I could switch between the sensors, I had each sensor labeled a dial, and then 3 registries: a selection for the dial, or the dial setting, which is under selection, and of course again the azimuth and elevation, which is the horizontal and vertical. Okay, still have the same offsets as before. Load, selection, dial setting, and then did a branch equal to 0, jump to north, 1, jump to east, 2, jump to south, 3, jump to west. And then I just basically just copied the code in for north and east. It's literally from north to start here. Just change out north with east, south, and west, and it's the exact same. But of course, in each one also the sensors. This is in sensor, east is E sensor, south sensor, west sensor. So then you can just go and whenever it finishes with whatever chunk it has jumped to, it jumps right back to start, goes through all this again. So if you changed it, then it'll go to the next one. Right here on the top of this locker is everything that you need to make just a very simple and basic solar array. This is just one for 4 panels, but you can expand it out to as many as you'd like. Okay, so in this we just got 4 panels, 4 sheets of glass, a sensor kit, a power controller kit, battery. Large is usually better. You can probably do it with small. I don't know if the small battery will actually last. 4 logic IOs, 2 logic processors, 2 memory, and in the setup that we're doing, 55 cable. And just as a little added bonus, we're just going to put a little light in there as well. So let's just start pulling everything out. Yeah, I don't need this with me, but I will need cable. Alrighty. And we'll set it up right here. So first thing, we actually want the solar panels. We're going to go with the singles, and we're going to have them to where they are pointing east. Just plop 4 down. Then just complete them with glass. 1 glass sheet apiece is all they need. Then the really fun part. We won't quite do the wires quite yet. We'll actually just throw down the sensor first. Okay. Then the power controller. With the power controller, make sure it's going the correct direction. Otherwise, nothing's going to work. And we'll go and throw down the light. Let's do diode. Okay. Then we need a couple of logic processors. So we're going to kind of be doing this backwards a bit for placement. So we're going to start with a batch writer. Then we're going to go with a logic reader. And this is going to be our horizontal. Then we're going to come back to another batch writer. This is going to be for a vertical. Then this is where we need the logic processors. And then just logic math. So we need 1, 2, then another logic reader. And this is going to be all the vertical. Throw down 2 memory chips. They just need to be in here. Doesn't have to be great, just in here. And this way we have all of our data that's going to be down here. The power coming from the solar panels will also be down here. And then powering the logic circuits is all going to be over here. Okay. If you should have a label maker. Pull it out and time to start labeling. So this is going to be vertical. Pick whatever name works best for you. For me, this is what I found works best for me. Vertical 1, because there's 2 logic maths. There's one that I got to go through first, and then one that I got to go through second. So this means this is going to be vertical 2. Okay, and then the memory units, same thing. Vertical 1 and vertical 2. Then for the batch writer, vertical. Okay, and here we got the horizontal ones. So this one is going to be horizontal. And this batch writer is also going to be horizontal. Confirm, and well, that's the hardest parts. Now, cable. Ding. Oh, oh. There. Nope, 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 nope. There. Cable junction. 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 Oh. Yeah, yeah. So that and this one actually just needs to be a straight cable. Okay. Do 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 do. Then and then the last few cable. There, there, and there. So everything's wired up. Pry this open. You've probably done this multiple times at this point. And screwdriver. So let's get this all set. Sun's getting ready to come up. I think we can have this done. Oh, wait, I just remembered. Some of these logic circuits, you can do a little cheat on. Memory. Nope, cancel. You can actually set the setting. So this is 2, so this is going to be the 1.5. Confirm. And here comes the sun. And here's 75. Confirm. So, in daylight sensor, variable, horizontal, on. Okay. In logic reader, horizontal, the only thing you can read. Output, solar panels, horizontal, on, And they're moving. Okay. Let's get that vertical done. Daylight sensor. Vertical. On. So, normal one that it can be. Logic reader vertical. This one you got to do some searching. So this will be memory 1. Logic memory vertical 1. We're going to do add. On. Okay. Then this one you might have to do some. You're going to have to do some searching. So we want math vertical 1. Then memory vertical 2. And this is going to be a divide. That comes on. Then the input of the batch writer is going to be vertical 2, math vertical 2. Output is going to be the solar panels. And of course, the vertical. Turn it on. And ta-da! We got power. And as you can see, they are tracking. Each one is at pretty much 100%. 99% efficiency. Hard to complain about that. Oh, yeah, see? 100%. 198 watts. So basically, think 500 watts per solar panel. You're going to be doing good, because that is 2,000 watts of power right there. These cables only can have a capacity for carrying 5,000 watts, which is also why I got those transformers there. So, hopefully you learned something. Good luck, have fun. See you on the next tutorial.